All right, so welcome to chapter 2. Here we're going to do an introduction to the fractions, starting with section 2.1, where we're going to take a look at prime numbers and talk about what they are, and divisibility rules. So rules to help you figure out if something is divisible by another number. So first of all, a bit of terminology. A factor. So a factor is a whole number that divides exactly into another number. So for example, 2 is a factor of 6. And this is because we could say 2 times 3 equals 6. Or in other words, 6 divided by 2 equals 3. It gives us a whole number. So if we were asked to list all of the factors of 24, well, 1 is always going to be a factor of a whole number because 1 multiplied by that 24 gives us 24. And then we need to think of what other numbers could we multiply together to get an even 24. Well, let's go up from 1. So if we have 2, we could have 2 multiplied by 12 to get 24. Remember, you've got that multiplication table on the first page of your formula sheet, which is really helpful here. Okay, so 2 works. Let's go to 3. So if we look across the 3 line, there's also a 24 because 3 times 8 gives us 24. 4 times 6 gives us 24. 5 is not a factor of 24 because there's nothing 5 multiplied. There's no number multiplied by 5 that you could get an even 24. We can do 5 times 5 to get 25. That's as close as we can get. Now 6 is a multiple, or sorry, 6 is a factor of 24, but look here, it's already been given to us there. So because we've kind of looped around now, we've already got to the 6, and that 6 is already mentioned. We know we have all the factors in this circle here. So the factors of 24 then we've listed here. So they're going to be, you could draw yourself kind of an upside down rainbow to figure those out. So you're going to have 1, 2, 3, 4, and then loop it around 6, 8, 12, and 24. Those would be all of the factors of 24. So what is a prime number then? People talk about prime numbers a lot. I really like prime numbers. What they are, they're kind of special numbers. They're whole numbers that have only 2 factors. Those 2 factors are going to be 1 and itself. They have to be greater than 1. So 1 is actually not a prime number. But for example, if you think of 2, the only factors of 2 are 1 and 2. So itself, the 2 and 1. The only factors of 13 are 1 and 13. My favorite prime number is 7, which I guess is kind of cliche and not that interesting. Lots of people like 7s. The only 2 factors of 7 are 1 and 7. 2, 3, 4, 5, 6, none of those divide evenly into 7. So 7 is a prime number. If you look on your formula sheet, so go 1 page past that multiplication table, you'll see the first 500 prime numbers are listed there, which is more than you'll ever need, but it does show you which numbers are prime. So you don't have to kind of guess, you can see them right there. Composite numbers are less well known. We don't talk about them as much. They're basically numbers that are not prime. So they're the opposite. So they're whole numbers greater than 1 again, but they are not prime. So for example, 18 is not prime because 3 times 6 would give us 18. Those are 2 factors then of 18. 25 is not prime because 5 is a factor of 25. 5 times 5 gives us 25. So those are the composite numbers. Basically, any other number on your sheet of those first 500 prime numbers that doesn't appear on that sheet, aside from 1. 1 is special. 1 doesn't count as a prime or composite number. Neither does 0. So 0 and 1 are neither composite nor prime. All right, so let's identify the prime numbers here. Well, you could use your sheet and you'll see that 2 is on there. 2 is always weird to me that it's prime because it's the only even prime number. But it is prime because only 2 and 1 are factors of 2. 6 is not. 9 is not. 11 Yeah, it appears there. 11 is not 15. 19 is, how about 23? I have to look at my sheet for that one. 35, no. And 41, yes. Okay. So those are the prime numbers. Now let's identify composite numbers. So once again, those are going to be numbers that are not prime. So 2 is prime, so we've got to kick that out. 6 is composite. It has factors, including 2 times 3, so it has factors. 10 is composite. In fact, every even number other than 2 is going to be composite, because then 2 would be a factor. 13 is prime, so it's not in there. 16, yes. 17, no, it shows up on your prime number sheet. 22, yes. 27, yes. And 35, yes. So basically everything that's not on your prime number sheet. Okay. So if we're trying to figure out if a number is divisible by another number, we could use our calculator, right? So we could say, well, is 12 divisible by 2? Well, I could go 12 divided by 2 equals and see if I get a whole number. But there's also these divisibility tests, which are nice because they're kind of shortcut ways to quickly decide if a number is divisible by another number, and that can be helpful. These rules are also given to you. So if you go to the prime number sheet of your formula sheet and then flip one more page over, you'll see divisibility rules for numbers 1 to 20, and that's basically what we have on this sheet. So you do have these for reference. So how do you know if a number is divisible by 2? Well, a number is divisible by 2 if its last digit is even, or I guess if the whole number is even, which means that the last digit is a 0, 2, 4, 6, or 8. So 2, 4, 6, 8, who do we appreciate? 0, because 0 is also in there. Okay, so those are divisible by 2. By 3, if you want to figure out if a number is divisible by 3, add up all of its digits and then see if that sum is divisible by 3. So let's do some of these. So down here, it asks us which numbers are divisible by 2 and 3. Okay, let's start with 372. So because it ends in that 2, it is divisible by 3 or by 2. How about 3? Well, we need to add up its digits. So if we're trying to figure out if it's divisible by 3, we're going to add the 3 plus 7 plus 2. So add up all its digits. What does that give us? So 10 plus 2 is 12. 12 is divisible by 3. So that means this number is also divisible by 3. Okay, next one. So 5,943, not divisible by 2. Okay, because it's not, doesn't end in an even number. Is it divisible by 3? Well, let's check. 5 plus 9 plus 4 plus 3 equals what? 14 plus 18, 21. 21 is divisible by 3. So this number is divisible by 3 then. All right, next one. Why don't you pause the video actually and try these next two on your own? Okay, so hopefully you had a chance to try these on your own. Let's try them together. So this next one does not end in a 0, 2, 4, 6, or 8, so it is not divisible by 2. How about by 3? Let's add up all those digits. And we get 21. 21 is divisible by 3. Okay, and you can figure that out because it'll be on your chart under the 3 row for your multiplication chart. Or you could go 21 divided by 3 and you'll see it gives you an even 7. So that's divisible by 3. That means this big number up above is yes, divisible by 3. And that last one there, it ends in a 0, which means it's divisible by 2. Is it divisible by 3? So again, we're going to add up those digits. That gives us 14 plus 8, 22. 22. And 22 is not divisible by 3, so this number is not divisible by 3. Okay, let's go back. So those were the first two rules. Those are kind of some of the more important rules, I would say. Another important rule is by 5. So a number is divisible by 5 if its last digit is a 0 or 5. So if it ends in a 0 or 5, yes, it's divisible by 5. 4 is interesting. If you want to figure out if a number is divisible by 4, you can ignore the whole number except for the last 2 digits. So if the end 2 digits are divisible by 4, then the big number is also divisible by 4. So let's do some of those. So this first one, we have 6,456. We can ignore the big number and just concentrate on the 56. So is 56 divisible by 4? Well, let's go to our multiplication chart and let's look down the row of 4 and see if we see a 56 there. And we do. So it's divisible by 4. The 56 is divisible by 4, which means that larger number is as well. All right, go ahead and try those next two. Pause this video. All right, and so we've got 242. We're going to look at the 42. Is the 42 divisible by 4? No, it is not. So that means this big number is also not. Okay, the next one's maybe a little bit tricky. We're looking at this 0 here. Is 0 divisible by 4? Well, we would have 0 divided by 4, and we know 0 divided by 4 is an even 0. It's a whole number. So yes, it is divisible by 4. It's a bit of a tricky one. Okay, divisible by 6. Now, 6, I don't know. You can do 6 using your calculator almost as easily, but let's take a look at the rules anyway. A number is divisible by 6. Basically, if it's divisible by both 2 and 3. So if it's even and if its digits add up and are divisible by 3. So to figure out if this is divisible by 6, let's first figure out 2 and 3. Then we'll know 2. Then we'll know 6. So 6,456, it ends in a 6. So yes, it's even. Is it divisible by 3? Well, let's add up those digits. 6 plus 4 plus 5 plus 6. That gives us 21. 21 is divisible by 3. So this big number is also divisible by 3. That means it is divisible by 6 because it's divisible by both 2 and 3. All right, next one, 242. Is it divisible by 2? Yes, it is. Is it divisible by 3? Well, 2 plus 4 plus 2 gives us 8. 8 is not divisible by 3. So this 242 then is also not divisible by 3. That means it's also not divisible by 6. Go ahead then and pause this video and try this next one. Okay, let's do this next one together. So is this number divisible by 2? Well, it ends in a 0, so yes. Is it divisible by 3? Let's add up the digits. 2 plus 2 plus 1 gives us 5. 5 is not divisible by 3, so this number is not divisible by 3, which means it's also not divisible by 6. All right, let's look at the rules for 9. So a whole number is divisible by 9 if the sum of the digits is divisible by 9. So it's kind of similar to the rule for 3. Okay, so let's figure out if this first number here is divisible by 9. So we're going to add up our digits. So 3 plus 4 plus 5 plus 6. What does that give us? So 7, 12, 18. 18 is divisible by 9. If you look at your multiplication sheet under the 9s, you'll see 9 times 2 is 18. So 18 is divisible by 9, which means this big number is divisible by 9. Okay, let's take a look at the next one. If we add up those digits, we get 2 plus 4 plus 3, that's 9. 9 is divisible by 9. 9 divided by 9 gives us 1. So that means this bigger number, 243,000, is divisible by 9. Kind of cool, right? Because you wouldn't know that you could just say, can I divide evenly 243,000? It seems ridiculous. But using these rules, you can figure that out pretty easily. Okay, last one. Go ahead and try this on your own. Okay, and so we're going to add up the digits. When we add up those digits, we get 6. 6 is not divisible by 9. So that means this big number is not divisible by 9. And the last of the divisibility rules is divisible by 10. So a number is divisible by 10 if it ends with a 0. Okay, so this first number here ends with a 0, so yes. Next one, no, we end in a 2, so that is not divisible by 10. And last one, once again, ends in a 0, so the answer here would be yes.